Hello, my name is Claire Oliver, and I'm a sales engineer with Rocket Software. Today, I'll be walking through a systems programmer daily health check with Rocket EVA. Imagine a scenario with a lead systems programmer beginning their morning operational review. The environment is stable, but there are thousands of metrics, alerts, and performance indicators to evaluate. Rather than sorting through static dashboards and performance data, they ask EVA to identify the top 3 conditions that would impact the environment if left unaddressed. The prompt is, if you were the lead systems programmer, what are the 3 highest-ranking conditions in the environment today? Explain why they matter and recommend preventative action. Looking at EVA's reasoning, we can see it determining which operational metrics are most relevant to answering the question, including CPU utilization, paging and memory pressure, and I/O device activity. EVA retrieves that information through the RDV MCP server and analyzes it to identify the highest confidence risks in the environment, helping systems programmers focus on the most critical issues before they develop into larger operational problems. Starting with the highest ranked condition, EVA has identified elevated FICON channel saturation on SYS1. The response explains why the issue matters, highlighting how sustained channel saturation can increase I/O response time and create downstream performance impacts that spread across the environment. The second ranked condition is sustained CPU pressure and increased wait time on SYSPLEX 1. Rather than simply reporting elevated CPU activity, EVA explains the operational significance of the trend, noting that sustained CPU contention can increase transaction latency, extend batch processing time, and reduce overall system responsiveness. The third condition involves paging and memory contention, including the presence of an anomalous high-severity record. EVA highlights the unusual nature of the event and correlates it with surrounding system behavior. No green screens, no static reports, no manual correlation of data. EVA immediately highlights the issues and helps teams determine whether additional investigation is warranted. Throughout the response, EVA provides the evidence used to support each assessment. This allows users to validate the findings and understand the reasoning behind the conclusion. EVA also prioritizes the conditions based on overall operational risk, helping users focus on the issues most likely to impact availability if left unresolved. Teams can quickly drill into underlying operational data, as opposed to spending hours manually piecing data together. For each condition, EVA provides both immediate investigative actions and longer-term preventative recommendations. The response concludes with a bottom-line summary that brings the findings together, helping users quickly understand the overall health of the environment and where they should focus their attention first. At this point, a traditional report or dashboard would stop. The systems programmer would need to begin a separate investigation to determine which condition poses the greatest operational risk. With EVA, the conversation continues naturally. The user can ask follow-up questions and explore the findings in greater detail without having to start over or manually gather additional data. In this case, the user asks which issue is most likely to cause an outage in the next 7 days. EVA evaluates the previously identified condition and determines the DB2 production subsystem represents the highest near-term outage risk. Rather than simply restating the original findings, EVA performs a deeper assessment, examining how multiple indicators interact and contribute to overall operational risk. Individually, increased statement pool failures, elevated CPU usage, and declining hit ratios may not be alarming. However, when you put them together, they form a pattern that suggests mounting pressure on the subsystem and increasing risk of application instability. EVA helps move from diagnosis to action with clear recommendations on next steps. Instead of moving between dashboards, reports, monitoring tools, a system programmer can simply continue the investigation through a single conversation workflow, using each answer to guide the next question and move teams from awareness to decision-making. In this example, EVA first identified and prioritized the most significant conditions in the environment, then used a follow-up question to determine which posed the greatest outage risk. The response not only explains the risk, but also provides guidance on where to focus investigation and remediation efforts next. For teams responsible for maintaining system availability, That means reaching conclusions faster and spending more time addressing issues before they impact production. That's the difference between reviewing data and having a conversation with it. Thank you for joining me today, and thanks, EVA.